Hi everyone. In this video I'm talking a little bit more about operator math. I want to review some of the concepts we talked about in class and also get some practice with some real operators and real functions. So if I've got an operator A and it's acting on a function like that, it's important to note that the function goes on the right side of the operator. It does not go on the left. So you would never see something like this. That's not okay. Also, it's possible for operators to add together. So I could say that I have an operator A hat plus B hat like this, and I could say that these two are operating on a function like that. And the important thing to know about this is that the function can be distributed to each of those operators. So this is equivalent to saying A hat F plus B hat F. Notice that I'm putting the function on the right side of the operator, like that. Now I could say that even though it is two operators adding together, I could say that A hat plus B hat is equal to C hat. And so, therefore, it's perfectly valid to write that A hat F plus B hat F is equal to C hat F. You might see that on occasion. How about if two operators are acting in succession? If I have A hat that's acting on B hat, that's then acting on F, it is important to note that the operators will act from the ones that are closest to the function outwards. So you would first have to apply operator B, and you would have to apply operator A after that. What you cannot do is, in the case of operators acting or multiplying is another way to say it, but usually you'll hear me say acting on. If I've got two operators that are multiplying and acting on F, then you would not distribute them. So you would not go A hat F, B hat F, or something like that. That's not okay. So you would never do that. The function only distributes in the case of adding operators. Now, you're very likely to encounter a situation where operators are both acting on each other and maybe also being added to some other operators. So you might see A hat acting on B hat, and then being added to C hat like this, and all of those acting on a function. And all you've got to do is just remember the rules I told you about above, and the result is just A hat acting on B hat acting on F like that, plus C hat. By the way, you distribute with adding operators and also with subtracting operators. So this would just be A hat acting on B hat acting on F minus C hat, like this. And I'm not using the same C hat as I did up here. I'm just using it as a generic symbol for a general operator. It's very important to remember that the order that the operator is applied does matter. So in general, if A hat acts on B hat acts on F, that is typically not the same as B hat acting on A hat acting on F. And that is because, in general, operators do not commute, where commute implies that it doesn't matter which order you apply them in. Okay, let's see some real examples here. One type of problem you're fairly likely to encounter in your homework is you're provided with two operators and then also a function. And they'll give you an actual operator and they'll give you an actual function. So let's say that operator A is the derivative with respect to y, and operator B is just y itself, and that our function is y times e to the negative 2y cubed, like that. I'd like to point out that operators can be either constants or functions themselves, or they can be derivatives. They can be more than that too, but these are the main types of operators that we're going to encounter in this course. So first it wants me to find the result with the operators applied in this order. So how would I write this? Remember, I've got to apply B to F first because it's the closest one. You really can't apply A to B. That will definitely give you the wrong answer. You have to apply whichever operator is closest to the function. So when I actually write out what this means, it becomes the derivative with respect to y of y times y e to the negative 2y cubed, like that, which I can just rewrite as d dy y squared e to the negative 2y cubed. Okay, when I actually calculate out what this is, I'm going to use the product rule. There's my first function, there's my second function, and they're being multiplied times each other. So I take the derivative of the first function, leave the second one alone. And then I add it to the first function left alone times the derivative of the second one, e to the negative 2y to the third, times the derivative of that one up there, which becomes negative 6y squared. And then I'm going to simplify this out, make it look a little bit nicer. E to the negative 2y to the third plus, let's make that minus 6y to the fourth e to the negative 2y cubed, like that. Okay. Now, the problem might ask you to apply these operators in the reverse order as well. So let's go ahead and do that. Let's calculate b hat acting on a hat acting on f, just to prove that in general operators don't commute. When I write out what each of these things means, I get y times the derivative with respect to y. I've got to make sure to put those parentheses in order. E to the negative 2y to the third, like that. When I calculate out that derivative, I should get y times e to the negative 2y to the third times negative 6y squared. And then when I simplify this out a little bit more, I get negative 6y to the third e to the 2y cubed. Okay? Notice that this result is not the same as when I had a hat acting on b hat acting on f. So that was a proof, really, that those two operators do not commute. Okay, let's see one more highly complicated example just to really drive the point home. What if I told you that our operator is going to be 1 over 3x, and it's going to be acting on 3x squared plus 2y squared, and that's going to be acting on a derivative with respect to x. And all of this is going to be plus 2y squared. All right, so that's going to be our operator. So we can call this a hat. And then our function, let's choose a fairly simple one just so that we don't get too carried away. 3x to the fourth. Now, I would like to point out that this big operator is actually composed of several smaller operators. So I could say that that's b hat right there. I could say that that's c hat right there. That's d hat. And then this maybe could be e hat. Something like that. So really, when I do a hat f, that's equivalent to writing b hat acting on c hat plus d hat. And that's all acting on e hat. And then this is being added to this little guy right here. I forgot to give him a name. G hat. Okay? And then all these things are acting on my function f. So the first step is to apply the rightmost operators to the function. And since the rightmost operators are involving an addition, then I need to distribute my function out like that, because the first operator is being added to something else. So that's an indication that I need to separate them out. So then this becomes B hat, C hat plus D hat acting on E hat, acting on the function, plus G hat acting on the function. Okay, let's do E hat acting on the function. That's just the derivative with respect to x of 3x to the fourth, which is just 12x to the third, like that. Now I'm going to calculate G hat acting on f, and that's just going to be 2y squared times 3x to the fourth, or 6x to the fourth y squared, like that. And I'm going to save the G hat f for a little bit later, because for now I want to finish up applying these operators over here and see what we get on that side, and then we can add it to what we get to the G hat f. Okay, next I've got C hat plus D hat, and these are just acting on my new function, 12x to the third. And what makes the most sense to do right now is to distribute that function to the right side of both of those operators. So that becomes C hat 12x to the third plus D hat 12x to the third. And when I write out what the C hat and D hat operators are, I get 3x squared times 12x cubed plus 2y squared times 12x cubed. When I simplify this out a bit, I get 36x to the fifth plus 24x to the third y squared. Okay, so now I've applied the C and D operators. The last step is to apply the B hat operator. So B hat of my function 36x to the fifth plus 24x cubed y squared. All that is just 1 over 3x times 36x to the fifth plus 24x cubed y squared. And then I can distribute that 1 over 3x, and I should get 12x to the fourth. I'm just distributing this times that, and then also times that one, plus 8x squared y squared. All right, we're almost done, but not quite. Now the final result, adding back in now this G hat of f, is going to be 12x to the fourth plus 8x squared y squared plus 6x to the fourth y squared. And that's it. That is the end of applying that very complicated operator to that function.